In this video, we're going to have a look at performance testing our ECS and Lambda workloads that we've been deploying and building to date. Performance testing is really great to get a sense of how the infrastructure performs and what kind of challenges that your users may experience when your application's under high load. So in this case, we know Lambda is a fantastic serverless platform and it will scale very, very well based on load and stuff coming in, but we also want to see how quickly it can tolerate that load and when do the wheels start to fall off, what are the limitations. And then the same for ECS, so managing those containers, what do we need to be concerned about, how many containers are we going to need, how quickly would we need to scale those containers. So we're going to have a bit of a look at what we can do with all of that. There's many frameworks and tools out there for achieving this kind of testing. Historically, tools like JMeter and Gatling have been fantastic for performance testing. I'm going to introduce a little bit of browser testing today. So for anyone familiar with Selenium and Selenium Grid, there's a plethora of tools out there in that particular space as well. Tools like Robot Framework and Playwright. Today I thought I would have a go at using Grafana's K6 as just an alternative to all of those. And the benefit of K6 is that they're kind of aiming to keep its DSL in parity with Playwright. So anyone familiar with Playwright tests and stuff like that at the moment, this is a tool that's potentially really useful to migrate your projects across to as well. Just on that, Grafana Cloud is a paid service. I'm just letting you know that this is not a sponsored video. I've just chosen to use K6 and showcase it for my own purposes today. So just having a quick look over here. This is the dashboard when you log into Grafana Cloud. I've set up a couple of tests, one to capture our browser test results and one to capture our load testing we're going to do under HTTP conditions today. But yeah, if you have a bit of a look here, there's plenty of stuff. Anyone familiar with Grafana, obviously you've got dashboards and metrics and all sorts of other stuff you can set up. We're going to be working in performance testing and synthetics today. There's infrastructure monitoring, application monitoring and metrics and all sorts of stuff you can do. It's actually quite a good platform. It's not too expensive, definitely worth having a look at, and even their free tier. So anyone wanting to run their own home projects or try stuff out, even for your work projects, they actually give you, if you look up here, you can see I've got 500 virtual user hours that are available to me, and this resets every month. So you can imagine 500 users running flat chat for an entire hour. That's quite a lot of load. With one caveat with the free tier, they do actually limit concurrency to 100 virtual users at a time. So you could run 5 1-hour-long tests of 100 users, or you could run a subset of that. Today we're going to run a test suite that's probably going to run for a minute or two. So we're not going to use a large amount of those. You can actually see I've run through these particular tests recently just to kind of make sure everything's working, and I've used 1 out of my 500. So you get a lot of bang for buck out of even just the free tier of this. So I highly recommend checking it out. So yeah, I'm going to show you those performance tests, but I thought I'd just quickly show you while we're here the synthetics. If we create a check in here, we can actually go and set up something that's going to run, say, a regression suite that's going to go through our website that we're running and just make sure that everything's working as expected. So if we pick this browser one here as an example, they even give us code example that's pretty much ready to go. So you could add your website here. This one's actually doing login. So if you need users to log in, you can configure one to do that. If you're testing just a publicly available site, you can configure what you want the browser to do, which pages to navigate through and verify. And then all of this can be hooked up with alerts, and you can specify when you want it to execute. So it's actually quite a good tool. So you can think if you've got a website that maybe takes your test suite 10 minutes, 15 minutes to kind of walk through and just kind of verify that all the checks and everything's healthy, you could schedule that to probably run daily, a couple of times a day, and still fit within your free tier on Grafana. So it's quite powerful. Definitely recommend looking at those paid tiers though if you've got teams and other requirements. You want to expand your load testing past those 100 virtual user limitation that we're going to hit today. Documentation's really good too. The team's done a great job. Going back to those browser tests, you can see here there's some more examples of how you could configure things. I've borrowed one of these today to base my browser tests on. Very well documented, well explained. They walk you through a lot. You can jump in and check out their HTTP module as well. We're using this one today for our load tests. They got some basic examples in here of how you would configure and utilize that as well. You can set up your fixtures for test content that you may need to post if you're doing that kind of thing. So, and metrics, you can check out all of this kind of stuff. They got heaps and heaps of data and stuff that they capture. It's a very good tool. Let's jump across to our repository over here. One thing about K6, which was handy, it's all Node.js compatible. I believe the tool itself is actually written in Golang, so you've got a static binary that's going to actually do the performance testing. So it's lightning fast, but it's compatible. The syntax for configuring your test suite is all based around Node. So you can have a look over here. This is my browser test. I've got this set up so I can actually run it locally, and I can also use it on Grafana Cloud. So you can see I've got my project ID configured here. When I do run it in Grafana Cloud, it knows which project it's running to. I've configured my zone that I'm running against. We've been deploying our workload into the Sydney region in AWS. So obviously I'm going to run my tests from there. I'm more interested in how quickly the service responds to things. I don't want to deal with global or other regional related latencies. I can run it locally here. I'll demo that in a minute. And you can just see our test is fairly basic in this case. We've got a single page app, doesn't really have any links or navigate anywhere, being the default React app. So the browser is going to connect. It's going to navigate to our target URL, which at the moment is localhost. For our deployed workload, it's going to be our load balancer endpoint. And then we're going to come in, we're going to take a screenshot so we can actually see what the user would be seeing. So we make sure we're getting the right kind of content. We're then going to have a look through the page when we're going to dig out this save to reload text that we're seeing. And we've defined this as a check. So if we're expecting certain things to be there, we want to write checks for those, and that'll give us a tick or a cross to kind of say, hey, yes, things are as you expect or not. So you can imagine if you've got a daily regression running that's checking your site, teams are constantly working and delivering things. If something changes that's unexpected, those checks are really handy to inform you with what's going on. So very simple test here, pretty much in line with the docs that I showed you just a moment ago. I haven't done too much more to it. I've just set it to a single user in this case because it is literally just loading the page and looking for content. If I move over to my HTTP test here, this is where we're doing load testing. And I've created this context of profiles. This is not something that they document themselves, but it just allows me to kind of configure, the amount of users I want and put the timings around ramp up and duration of test cooldown, as you can see here. For our cloud test, so we've set that on the free tier. We have a maximum of 100 VUs, so I've configured it to that maximum. And then locally, I've set it up to be 50 users, and the local development environment is there for me to be able to build these tests and just verify everything's working as expected before I start consuming cloud resources. So you'll see down here for the configuration, project ID for our tests has been configured there. Obviously Sydney region still, and then our stages, this is what's referring to those profiles above to get the VUs and the ramp up, duration and cooldown values. Down here we can see our homepage request. I've pretty much made this mirror what we would do for the browser testing. So it's going to go and download the HTTP page, our main page, and then it's going to go and get the JavaScript, the CSS, the images, icons, etc. You can see the files here. So if you were to look at the output from the browser test that I've got here, which is just navigating to that main page, obviously your browser is going to pull down all content automatically for you. You don't need to worry about it here. The output from that is effectively what I've taken and put into this request. If you've got multiple endpoints, other pages, things like that you want as part of a performance test, which you probably do in a larger application, you could specify multiple sets of these, and then you could have those run in your tests as well. Something else to note, I've actually got a sleep at the bottom here. I'm sleeping for half a second. So the way these tests actually run, while this is active, we've got 100 virtual users running for approximately a minute. It's going to execute, do this request, sleep for half a second, and then run the next request, and it's just going to repeat that for the entire time. So we're actually going to be getting slightly more than our 100 user requests, or in this case we actually care more about the individual requests for each file that's going through. So there's going to be more than 100 requests a second in this particular case. So to make this stuff kind of easy to work with, I've added some tasks into our makefile. So you can see I've got some browser test tasks here, which we're able to run those browser tests and actually just see what's going on. We can run them locally and we can run them on the cloud. So this is the Grafana one. And likewise for the performance tests, I've got the local tests here for development purposes, and then we can also run them in the cloud. Also, just because I can run them against Amazon locally as well. So there's a lot of different ways that we can actually run this. Grafana pretty much has everything via its K6 command line tool, which is fantastic. You can stay in your development environment and run all these things while you're developing it, and then you can have it deployed into cloud where you can have it scheduled and run it regularly. So it's a really good product, and I certainly recommend everybody check it out. So having a look at the tasks and stuff that we've got today, let's go and run our browser test locally and just have a quick look at what that does for us. So I've set the makefile up. It's going to stand up our local container, which is what you can see that hash there from Docker. It's then going to run our tests. If we jump across here, we can see the logs from that container. We see Nginx started. We can see the requests are actually being made. And that's flowing through. It's finished now. We can see our status is okay. It's managed to check everything, and it also found our save to reload text, which is fantastic. Output from Grafana, really, really nice summaries here. So you've got your 90th and 95th percentiles of your requests made. Obviously, this browser test being a single user, this data doesn't really mean a lot as far as averages go. But you get your minimum and your maximum. So you can imagine during a load test situation, this data is going to be a lot richer, which will be fantastic for what we want. I've configured this to also output reports. So we get our results. So we've got our nice little summary here, but we also get a CSV report. And there's different options for this. We could have a JSON format, a couple of other ones. Please refer to the docs for your different outputs, but CSV is just as good. So if you need to run this in a pipeline and then you're going to take all this data and put it into another platform that you're going to be creating dashboards on or something like that, assume whether you're using Grafana's cloud offering or not, yeah, it's fantastic. Everything's in these files. And given that we just done a browser test right now, we've also got screenshots. So there we go. We can see our React app was started, and we can see our text is there. The image has downloaded. And we've just taken a few screenshots because it's gone and repeated what it was doing over the time that browser test was running. So really handy, be able to do that locally. We can run that against the cloud as well. If we go back into our make tasks, we've got our browser test against our Amazon deployment. So this is also going to run locally, but this time round, if I use make, we're going to run this directly against the AWS deployment that's been configured. So we've got our load balancer in here. For our stack, you can see from the previous testing that I was doing earlier today, I've got some data in here for load that was going on. I've also got Lambda deployed, so same deal with previous tests that I was running. CloudFormation, if you'll remember from the previous videos, we've got our Lambda instance deployed, and we have our Lambda target group. So all the tests at the moment are going directly against Lambda. There is no ECS deployment at the minute. So come back over here, and we can see our tests have now completed. And if we go back in, we get our results. We can see that it's been going to our load balancer over in AWS land. And we've got another set of screenshots. For some reason, missing the image. It may have been a little bit too quick capturing the screen there before the image had loaded. Something to look into in future. But yeah, so with our makefile, configured the ability to run these tests in a local context against Docker. You can then run them against the workload in the cloud, and then eventually you can tell K6 to run them in the cloud for you to capture and provide you the dashboard. So yeah, please check this out on the repository up on GitHub. I've got all the code and everything all committed and shared there for you to check out. Let's move across to our load test. We'll run this locally now. So using our local load test make task, we'll be able to run up our Docker container like we did on the browser test, and then we'll execute our 50 concurrent virtual users as we did before. And if we come across here, we can see all the requests coming through on our local Docker instance. So K6 is going to go through and run through all those tests across the 60 seconds that this particular test is going on. So you can see you can quite easily work on these files and maintain or test your local changes, I guess. So you got your local development environment before you start trying to run stuff against the cloud. So once this one finishes, what we'll do is we'll run our browser test up in the cloud, and we'll have a look at what kind of output we get from Grafana. Okay, so there we go. We can see our homepage load check has passed. We've moved 500 or almost 600 megabytes of data. We've got our averages here, 90th and 95th percentile for our request times, which obviously are pretty fast, being that we're running locally. And we can see how many requests a second. So you can see we're doing 25,000 requests total and 560 requests a second. So even though we're only running 50 virtual users, given that they're running several requests each iteration, and they're requesting multiple files, I think there's about 6 or so requests that we're running, 7 requests twice a second. Yeah, we're easily able to have quite a substantial amount of requests run through. So let's run this in the cloud now. So if we have a look at our makefile listing again, we've got our browser tests up here, and we want to run on the Grafana cloud. So let's grab this make task. And this is going to take that exact same script we ran locally before for the browser testing, did our screenshots, and it's going to go and upload it to the cloud and start running that for us. So this, we can see it run through all the different states locally, and then when it's complete, we'll be able to see it inside the cloud dashboard. So it currently says it's initializing. If we jump over here, we've got our browser test. So we could be running this as a synthetic, but just for today, we're going to keep running under these 2 performance projects that I've created. So HTTP for our load testing results, and browser for our user testing, which we're doing at the moment. So we can see here our test is initializing. And give it a moment to load up. I'll skip the animation while it's running the test. If we jump back across to our console, we should be able to see the current status. So we're still initializing. So what Grafana is doing behind the scenes is provisioning a resource to execute that test in the region that we want. So this is the Sydney region for AWS at the moment. And once that resource is ready to go, our test will start executing. It seems to be taking a little bit longer. I might speed this up. Okay, and now we can see our results have come in. So not particularly great on the first paint of the screen. I'm seeing a 3-second time there. I have seen this kind of result a few times with the Grafana results, but if I'm loading my application myself, I'm not actually seeing that. So I haven't quite worked out exactly why we're seeing that really slow start on initial request, but otherwise everything else seems to be going quite well. We've got our nice little timeline chart here of our requests and what's been going on. our different metrics, whether it's the first input, how long it's taking to paint, how long it takes for that first byte to actually come through. We get some insights, which is super handy, and then all our checks that we've been running just to make sure everything's successful. So it's quite cool. If you've run multiple, you can actually compare them. So I can compare this to one that I ran earlier, and you can see that they're very similar in the results, given that we haven't really changed anything. It's the same workload that's running, but yeah, quite nifty in what it does there. So let's go and run our performance testing this time around. So in this case, we'll run this one here, our load test, run on Grafana Cloud. We'll kick that one off. And it's going to go through the same kind of process of uploading and initializing things, and then spinning up the resources to execute the tests. So I might speed this one up as well, and we'll get to the results. So we can see here we've kind of got a bit of a live view of what's going on with our requests. And we can see up here our request rate is currently sitting around 1,200 requests, maybe a little bit more per second, which is quite reasonable. It's quite a decent test. So if you think each of those requests could be a transaction, if you had like an API that was doing financial transactions or anything like any other kind of request where you're expecting some data to be handed over and a change to be committed and then a response to come back, being able to handle 1,200 requests every second is quite impressive. So even off the bat, with our restriction of 100 virtual users with Grafana, we're still actually able, with these kind of tests, depending on how you structure your tests, you're actually able to get quite a high rate of requests to validate it against. So we can see here, looking at our insights again, our reliability is good, system's good, all these best practices that they've checked for us. 95th response time, 49 milliseconds, so everything's pretty fast, which is great. We didn't get any failures. Good to know. If we drop down here, we can see each of those individual requests that we've done and their various times for downloading. So it's quite interesting what they can actually bring through. You can review your scripts. We haven't configured any logging in this case, so if we do actually log from our scripts, we can capture some additional detail in here, as well as doing some tracing, which is pretty handy. No browser in this one, that was our previous test, but we've got some analytics we can actually dig in. This one I actually found quite handy for instances where we may have found some saturation in the underlying hosts that we were targeting. So you can actually filter based on CPU and memory usage here, and this is for the hosts that are actually generating the load. So you can actually see how much. So you can see based on this instance that we're currently running now, we're hitting up around 80% CPU utilization running this test, which to me is good. We've got a little bit of buffer there, so we know that the test suite's being run as efficiently as it possibly can. If we were to push it harder than that, so it's got more work that it's doing, it's bumping up against 100%, we might actually even see our request rate drop. We're not getting a true test of performance in that case. We're probably wanting to head towards a saturation test to work out what our system's actually capable of, but at the minute, just for showcasing what Grafana's got here, we're just sitting with the 100 virtual users doing their requests. So we can see here that the test execution is healthy. We're not over consuming the test host. We've got our iterations and everything else that's been charted above, which is great. So yeah, it's a good little tool, definitely worth checking out. So that's our Lambda performance. So what we want to do now is switch across to ECS and actually see what kind of detail we get for that compared to what we've just got for Lambda. So we're going to deploy our workload, and we want our argument, I think it was deployment type or parameter. Nope, that's not what we want. Deployment type ECS. So we'll go through and redeploy our workload, so we're now running on ECS. I'll speed this up for you. We don't need to watch this. We've seen it in the previous videos. Okay, so our stack has been updated. If we jump across to Elastic Container Service, we should be able to see our new service up and running. We're still running a single instance in this case. All right, here we go. So in our cluster, one task running. We can see there's no metrics on it yet. If we jump across here, we refresh. We still have our React app working via our load balancer. So I'll give that a moment and that should come up with some stats, but we should be able to see our logs here from the request that we've just done. There you go. All right, so that's working. Let's go and run our tests against it again. So for consistency, we could go back, we can run our browser tests again. I'm not expecting that we're going to see much difference in the reports. If anything, they should probably be about the same, given that we were only running with a single virtual user when we did the browser test before against Lambda. Might see some response times that are a little bit faster than what we had from Lambda. We'll have to wait and see how we go there. But yeah, given that we've got a compute resource that's running all the time there, responses should be pretty good. So I'll speed this up just while we're waiting for that test to initialize and run. Okay, so let's have a look at our results. Our browser testing against our ECS instance. Interesting, we're still seeing the slowness with the first byte, so potentially something to do with the runner being spun up to do these tests. Given that we're seeing that consistent response each time these tests are occurring, we can see that our responses are very good. If we have a look at network, so we can see there's some caching there, hard refresh, everything's pulling down really, really fast, nothing's taking 3 seconds. So yeah, something else that's coming into the mix there. Otherwise, everything's pretty good. These numbers look very similar to what we had for our Lambda run. Let's compare. Okay, so we can actually see it it's very flat in the responses from the ECS instance versus the Lambda. But otherwise, yeah, much the same. So we're not noticing any difference. I wasn't expecting any real difference there, given that this is the browser-based test. Let's drop back over here. We're going to go and run our performance test again. So let's kick that one off. And this one should give us a little bit more interesting data. So we'll see what kind of responses we're getting from our ECS container versus what we've been getting from the Lambda service so far. So while this test initializes and run, I'll speed it up. Now that our performance test is finished, let's go across and have a look at the results. So we'll come into our HTTP test. Oh, we can already see on here quite a difference in the results. Let's have a deeper look. So we're pushing 1.3 thousand requests, so 1,300 requests a second. So we've already seen that we've managed to actually get more requests through in the time that we managed compared to what we managed to do with Lambda. So it's definitely a bit faster. Response times, 20 milliseconds, I think is pretty good too, about half of what we're at before. All the other checks are good. We've got our breakdown and averages across each of the requests that we've been doing. Let's do our compare to the previous run. Yeah, so we can see particularly this 95th percentile is quite interesting. So we can see the ECS instance is actually responding in 20 milliseconds across most of those requests, whereas Lambda was near to 50 milliseconds, which, to be honest, is actually still quite good. But given that you've got a service there that's running and only responding to requests on demand versus something that you're running all the time as a container, it's quite an interesting trade-off to work out whether Lambda is probably more beneficial to your deployment or not. I think this probably is starting to show that, you know, non-production workloads or environments where you don't necessarily require massive amounts of performance and throughput, Lambda's probably a really good fit and will give you a very good cost benefit as well in managing those environments, given that you can just deploy it and let it sit there. Whereas ECS, you'll need to at least configure scaling rules, but you're going to have a base load that's always deployed. Yeah, so we can see in here, very, very similar. I mean, we're only doing 100 virtual users at the moment, so nothing's setting the world on fire here with much of this data. So we're pretty much able to say at this rate that ECS and Lambda are certainly comparable, and Lambda for sure is going to be way more cost effective managing this, depending on the total amount of requests that you get for a given month. That's where you're going to start to see the dollars tick up for Lambda. Yeah, so you can see some of the upper limits on some of these requests getting quite high on Lambda. They've stayed fairly low for ECS. But all in all, really, really good. Both are showing quite good results. So yeah, anyway, so I thought that showing this K6 dashboard would be quite interesting. I think Grafana's done quite a good job with this. What I'm going to do, I'm actually going to have a follow-up video again for this one, because I really wanted to get to the point of saturation testing and possibly even trying to make something fall over. So what I'm going to do for the next video is actually configure it so that, similar to what we were doing for the local testing against our Docker container, I'm actually going to have a workload for doing tests that I'm going to deploy into the cloud, and we're going to run it directly there where we don't have the limitations that we get running on Grafana Cloud at the moment. So we'll be able to run the test suite as hard as we can. So I want to see what will Lambda get us to. At the moment, the deployment that we've got is limited to 1,000 concurrent executions. And ECS, we've got quite a small unit there with a single container. We want to see how many of those containers we need to be able to have a comparable handling of load to what Lambda's able to do. So I think that'll be quite interesting, and it will obviously give us a lot more information as far as which deployment's going to be more cost effective under load. So please join me in the next one, and we'll spin up that, and we'll see if we can make some stuff fall over and get some more interesting data to expand on this one.